Let's keep reading proofs. So I've reminded you of our checklist of what to do before and while reading a proof. And today we're going to do some supposed proofs. So I put the word proof in quotes here. So the real test of whether you're understanding the chain of logical reasoning is to detect whether a proof is correct or incorrect. So I put this proof in quotes because this may or may not be correct, and our job will be to determine whether this proof is logically valid. So is this correct? Okay, so let's go through our checklist. So the claim, which I've written here, is that if A is a subset of B and B is not a subset of C, so these are the assumptions. I can't talk, assumptions, then A is not a subset of C, so this is the conclusion. Okay, and we should remind ourselves of the definition of subset, so we say, maybe I should switch colors, so definition, so A is a subset of B if every element A in A also belongs to B. Okay, so we've gone through the pre-proofreading checklist, so we know the assumptions, we know the conclusion, we know the definition of the main word that appears in this statement. So now we're going to read through the proof and ask whether each deduction must necessarily be true. And this will allow us to judge whether the proof is actually logically correct. Okay, so the first sentence, suppose A is a subset of B and B is not a subset of C. So the goal of this first sentence is just to state the assumptions. So this sentence is stating the assumptions which are in the statement of the theorem. So far we haven't deduced anything. We've just kind of declared or defined our variables A, B, C and restated the assumptions from the claim. Okay, next sentence. Then, the word then signals that this should be a deduction. Then there exists an element x in B such that x is not in C. Well, why is this true? Well, this is true from the definition of subset, because we have assumed that B is not a subset of C. So if B is not a subset of C, it is not true that every element of B also belongs to C. So if it's not true that every element of B belongs to C, that means there must be at least one element in B that does not belong to C. You should think about that sentence and convince yourself it's true. If not every element of B is in C, that means there is at least one element of B which is not in C. Okay, so this deduction is true. Now the next sentence. Since x belongs to B, x belongs to A by the definition of subset. So it was true here that x is in B, and now we're claiming x is in A by the definition of subset. Wait, why is this true? Definition of subset. Well, our assumption was that A is a subset of B, but that means every element of A belongs to B. We're doing the opposite deduction here. This sentence claims that if x belongs to B, it must belong to A. That is not true. That is not true at all. That would be true if B were a subset of A, but we've assumed the opposite, that A is a subset of B. So this is false. False, and this is an incorrect deduction. So this is simply not true, and the remainder of the proof therefore must also be logically invalid. They then conclude that since x belongs to A, and x does not belong to C, thus x belongs to A and x does not belong to C. Okay, well, the second part is true, but the first part is not true, and therefore the author concludes A is not a subset of C. So in fact this proof does not go through because of this backwards use of the definition of subset. And we could have actually seen, if we had taken a moment to do exploration as though we were trying to prove this ourselves, we could have seen pretty easily, just by drawing a Venn diagram, that this claim could never have been true. The claim is that if A is a subset of B, but B is not a subset of C, then A is not a subset of C. Well, that's simply not the case, because we could have just, my pen is not working, but we could have simply drawn a Venn diagram like this, where here's B, and here's, whoa, here's a set C. My pen's flipping out, but if we just had A, which sits in the intersection of these two sets, then the theorem is manifestly false, because in the picture I've just drawn, A is a subset of B, B is not a subset of C, because B has this stuff over here that's not in C, and the conclusion claims that A is not a subset of C, but it is. We can see just by this drawing that A is indeed a subset of C. So just by drawing a picture, we saw this claim, this theorem could not have been true, but by going through and carefully finding the part where we use faulty logic, we've tested our ability to go through and check whether each deduction is actually true. Okay, good. So that's the end of this video.